Viewers, today I'll be explaining algebra basis for beginners. Now, let's have a look at example 1. Example 1 says x plus 2 equals to 5. Solve for x. To do this, we need these basic rules. The first rule says that when you have addition on the left side, because our objective is to let the variable x to be on the left side and the value to be on the right side. Now, what we need to do is that we need to eliminate every value that is with the variable x. Now, if the variable x has addition sign separating it from the other value, so then we need to introduce the inverse, which is the subtraction. And if it is multiplication, then we introduce division. And lastly, if we have an exponent, then we can introduce square roots and vice versa. Now, to proceed with this, here we have x plus 2 equals to 5. Now, we have addition, then we need to introduce subtraction. That is, we subtract 2 from both sides. So on the left side, here we have x, 2, cancel out negative 2, equals to 5 minus 2, which gives 3. So this is the rule for example 1. Now let's proceed to example 2. Now, in example 2, we have 2x plus 5 equals to 3. In example 2, we have two operators. Here we have the addition sign, which is plus 5. And secondly, we have the multiplication sign, which is between 2 and x. So we are going to solve this question addressing these two operators. But before we do that, then I need to introduce you to something called the PEMDAS. The PEMDAS will be applied to solve this problem. But you need to understand something. Using the PEMDAS, it should be from subtraction down to parentheses. That is, from down going upward. Now, the first thing we have to look at is, do we have subtraction? You can see that no. Do we have addition? Yes, we have addition. So let's deal with addition first. Now, to deal with addition, I told you if you have addition, you introduce the inverse, which is what? Subtraction. And here we have 2x plus 5 equals 13. Now, we have addition. If you introduce it, we have negative 5. Here we have negative 5 to both sides. And here we have 2x, 5 minus 5 cancelled out. 13 minus 5 gives 8. Now, we've done with the first operator. Now, let's apply the second operator. The second one is, do we have this division? No. Do we have multiplication? Yes, because here we're having 2 multiplied by x. And if you have multiplication, what do you introduce? You introduce the division. So that is, you divide both sides by the coefficient of x, which is 2, And here we have x equals to 4. Our objective is that we want the variable to stand alone. So now we introduce the first operator, which is the negative 5, and the second one dividing by 2. Example 3. In example 3, we are having 3 operators. The first one is plus 8. The second one is the 3 multiplying the variable x. And the third one is the square on the x. And we're going to use the same approach to do it. Now, the first problem is, do we have subtraction? No. Do we have addition? Yes. If you have addition, you introduce the subtraction. So that is, you subtract 8 from both sides. And here we have 3x squared. 8 cancel out this 8 equals 20 minus 8 gives 12. That is done. Now, you ask, do we have division? No. Do we have multiplication? Yes, we have. If you have multiplication, you introduce the division, which is the inverse. That is, divide both sides by 3, which is the value multiplying the variable x. Here we have 3, cancel out 3, x squared equal 12 divided by 3 gives 4. Now, going up, do we have exponent? Yes. The exponent here is the 2. So if you have exponent, what do you introduce? You introduce the roots. That is, you square root both sides. If you square root both sides, the rule of mathematics says that square root will cancel out the square. Here we have x. And what is the square root of 4? We have the square root of 4 to be what? To be 2. Yeah, you can say plus or minus 2, but here, yeah, you can put plus or minus 2, but I'm working with a real positive value, which is what? 2. So this is the answer to this problem. Now, if you look at this again, we use 3 operators: the subtraction, division, and the roots. Let's look at example 3. Example 4. In example 4, we have the same thing. We're having 2 operators here, but here we're having the variable x on the left side and also on the right side. What do? The first thing we need to do is to make sure we have the variable on one side, preferably on the left side. And to do that, you subtract 2x from both sides so that you can eliminate 2x on the left side. And what else do we have? 4x minus 2x gives 2x plus 5 equal 9. Now we have this. What next? Like I said, using this rule of PEMDAS, subtraction, no. Addition, yes, we have. If you have addition, what is the inverse, which is the subtraction? So you subtract 5 from both sides. And here we have 2x, 5 cancel out 5, 9 minus 5 gives 4. We've done with that. Division, no. Multiplication, yes. If you have multiplication, we introduce the divide. That is, you divide both sides by the coefficient of x, which is 2, by 2. And lastly, we have our x to be equals to 2. If you plug in 2 into the given equation, you will see that they are going to be the same. Next, we move to example 5. In example 5, here we have something called the absolute value. The absolute value. How does that work? When you have absolute value, we are interested in the positive and the negative of that value. For example, when I tell you I have absolute value of x, this means we have x, or you have, it can be negative x. So the absolute value only takes the positive value for the variable. That's what absolute value is. So the absolute value of negative 2 is just the positive side you take. It's going to give you. Now, here we have the absolute value of x plus 3. Here it means we have x plus 3 equals to 7. Or we have x plus 3 equals to negative 7. This is what it means. Now, to do this, I'm going to divide this into 2 using the same approach. Using PEMDAS, on the left side, here we have the addition. And if you have addition, the inverse is subtraction. That is, subtract 3 from both sides. Here we have x, 3 minus 3 cancel out, 7 minus 3 gives 4. If you do the same thing on the right side, negative 3, negative 3. Here we have x, 3 minus 3 cancel out, negative 7, negative 3 gives negative 10. So these are the values of x. Here we have example 6. This is also based on the absolute value. But before we apply absolute value, you will see that after having the absolute value, we have plus 6 equals to 9. Then we need to get rid of this 6 before we proceed using the absolute value. And to get rid of the plus 6, you have to introduce the negative 6 to both sides. And here we have x plus 1 in absolute value plus 6, negative 6 cancel out. 9 minus 6 gives 3. Then you can apply the rule of absolute value, which says that here we have x plus 1 equals to 3, which is the positive side, or we have x plus 1 equals to negative 3. The rule is still the same, addition, and the inverse is subtraction. So here we have x plus 1 equals to 3. Here we introduce negative 1, negative 1. 1 minus 1 cancel out. So here x equals to 3 minus 1 gives 2. If you introduce negative 1 also to this, 1 cancel out negative 1. Here we have x to be equals to negative 4. Now we have example 7. In example 7, here we have the square root. How do we deal with this? Using the same rule, which is PEMDAS. Do we have subtraction? Yes, we do. If you have subtraction, what is the inverse, which is addition? So here, rewriting the question clearly, we have x plus 3 minus 2 equals to 1. Now, introducing the inverse of subtraction, which is plus 2. Plus 2. Now we have square root of x plus 3 minus 2 plus 2 cancelled out. 1 plus 2 gives 3. Do we have addition? Yes, we do, but it is inside the root, so we don't deal with that. Do we have division? No. Multiplication? No. Do we have exponent? Yes, we do. If you have exponent, what do? Exponent to square root. This is what we have. Now, here we have the roots. What do you do when you have the root? You apply the exponents. So the exponent for the square root is squared. That is, for the square root, the exponent means you need to square both sides. If it is cube root, you find the cube root of both sides, so that this can eliminate the square root. On the left side, we have x plus 3. On the right side, we have 9. So, applying the same rule, which is when you have addition, the inverse is going to be subtraction. Negative 3, negative 3. And finally, we have our x to be equals to 6. And the last example, example 8. Here we're having two fractions separated by equals 2. When you have a fraction, a over b equals to c over d, the rule is that if two fractions are separated by equal sign, you cross multiply. And that is going to be the same rule we're going to use. So now to solve these two fractions separated by equals 2, we introduce cross multiplication. That shows that 4 multiplying x, we have 4 multiplying x equal 3 multiplying x minus 5. To solve this further, we need to distribute these 3 by multiplying x and also by multiplying negative 5. So here we have 4x equal, if 3 multiply x, we have 3x. If 3 multiply negative 5, we have negative 15. Now to do this further, we need to make sure that we have the x on the left side. And to do that, we introduce negative 3x to both sides, so that we can eliminate x on the left side, on the right side. So here we have 4x minus 3x, which gives x equal negative 15. So this is where we're going to stop. For you to confirm all the answers, you can plug in the value of x back into the equation, and you will see that they are accurately the same. Thank you very much for watching. Please don't forget to subscribe and also share this video. See you next time. Bye.